Hello and welcome to another video. This one's going to be pretty different than some of the other ones. I'm going over the architecture of how I migrated a Discord bot that's running in my Discord to Oracle Cloud from Heroku, and how I built it in about 15 hours, and it's kind of like a really bad Kubernetes. But I wanted to go over the architecture of everything, how I put all this stuff together, and how I incrementally arrived at the solution. Because going from zero to the end all at once never would have worked. But anyway, let's jump into it, and I'll show you all the parts of the code and how it all fits together. All right, so to get started, this was originally a project by one of my viewers, ShazRobot, who put this together so that some of the Twitch commands that I use in my Twitch chat could be used in the Discord. So for instance, if we go to my stream chat and I do explains, I don't know, Terraform, which we'll cover in this video, it searches all of my video titles and can give me nice little outputs there. And I use this bot all the time when answering questions in Discord, because it helps me link to videos directly without me having to scroll through the browser. Anyway, that's the point of this bot. The actual code of the bot isn't super important beyond that. But this was originally running in Heroku. Heroku had a nice free tier that had an always-on, what do they call them, pods? No, that's the Docker term, or the Kubernetes term. Anyway, they had always-on instances, which allowed you to write a bot and have it run forever for free. Heroku recently sunset their free tier, and so I was looking to other cloud providers for an always-on solution, and I found Oracle has a pretty generous offer for their free tier. And so I wanted to try out Oracle Cloud. I know, Oracle, blah, 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 enterprisey, their database is kind of annoying to use. Like, Oracle's kind of a weird choice here, but I wanted to try it out and see how it was. And my overall conclusion is that Oracle's pretty okay. Their free tier was really nice. There's a lot of stuff that it provides, and I am not sponsored in this video. I reached out to them to try and get them to sponsor me, and they're like, no, we don't have a budget for that. But anyway, this is my honest opinion about Oracle. I think their free tier is pretty nice, and I might use it in the future for other stuff. But I wanted to walk you through how I got to my final implementation, as well as what all of the parts look like. Now, the first thing that I did in order to try and spin this up is I wanted to prototype this. I wanted to get this working just by clicking through, manually running a bunch of commands, and seeing if this idea was going to work at all. So the first thing that I did is I spun up an Oracle instance, and actually I'm gonna scrub through my VOD really quickly to show you the original look at this. Yeah, this one. This is the second part of it. So I basically went through, manually clicked through the Oracle Cloud thing, created a compute instance, SSH'd into it, ran a bunch of commands, cloned down the bot, and eventually got it running. Now, Oracle's, this is me showing cred, so we're not going to show that. Now, Oracle's free tier is ARM-based processors versus your traditional x86 64. So I had to make sure that the project continued to work even on ARM, which was a lot of the difficulties. And I had to install a bunch of different software and make sure things built from source, and adjusted some of the code a little bit, but I eventually got it running. And that kind of proved out the idea that, okay, I can run this on Oracle Cloud. I can make it connect to Discord. I can basically get this bot running. Now I want to automate all of those steps in order to get there. Now, is automating these steps worth it? Absolutely not. It's a Discord bot. This is hilariously over-engineered. But I use this as a nice learning opportunity to try and learn a bunch of the technologies along the way, such that if I wanted to do this for a real production thing in the future, I would have that knowledge in place on something that's relatively low risk. The second thing that I wanted to do was to put this into a place where it was good enough while I was iterating on the automation, such that I could, tear down Heroku and not have to pay money. And my good enough solution was running the bot in a tmux session. Tmux is a terminal multiplexer. A lot of people are like, oh, you should use tmux for your day-to-day. I don't like tmux for my day-to-day, but it works really well for running a process in the background that just runs forever. And you don't really have to worry about it. You could even slap a while true on it in case your process exits or whatever. But this was kind of a nice little stopgap solution in between, running a full-blown managed container environment that would spin things up and spin things down. Oh, and on containers, there was no Dockerization of this before I got started, so we also did that as part of this process. Now, with this tmux thing in place, I was free to iterate on this project without worrying about, is the bot up, or, do I have to pay for Roku? So I could focus on doing this quote unquote the right way. I say the right way. My actual solution, there's still a ton of improvements that can be made, but I still wanted to go over the architecture of how I put it all together. All right, with all that in place, the first thing that I wanted to do in order to automate this was to go through and make a Docker image of the program that I was running. Now, I could install all the software directly to the host and make sure I'm building everything from source, but this had a few complications. The first being that there were a lot of dependencies needed to run this bot out of the start. Now, we actually reduced a lot of those, but at the start I needed a full compiler tool chain. I needed a Python extensions. I needed a bunch of dev headers. I needed the Python headers. I needed a whole bunch of stuff to get this to build and run. But also it was on an unfamiliar architecture, and so there was a lot of things that were a little bit fiddly. And Docker container made it a lot easier for me to just pull down a container image and run it. It also meant that if I were upgrading or downgrading stuff, I didn't have to worry about the state of the computer. I could just pull the whole application image and run that. So my first step was to Dockerize this. And the way that I took, or the approach that I took for this, is to make a pretty simple Docker file based on Jammy, install the dependencies that I need, set up a virtual environment, install the actual application, and then tell it when you run the container to run the Discord bot. Now, the Discord bot requires a few credentials. It requires a Discord token. It also requires an API token to talk to YouTube, and some small configuration to tell it what playlists to use and stuff like that. So this container alone was not enough to actually run. You need to feed it some environment variables, but that's pretty easy. You can just use --m to feed the right environment variables in. Okay, so we had a Docker file. I could build a Docker image, and I was able to run that Docker image. Now, how do I get that so that I can run it on a remote machine? In order to do that, I used a Docker registry. GitHub helpfully provides a Docker registry for you called GitHub's container registry inside their packages. And so we provided a Docker image, AWC video bot, which was the build output of that. Now, note here that there are two architectures here because, as I said before, Oracle VMs are running ARM. So I needed to build for ARM, but I also wanted to debug it locally so I would be able to play around with it in x86 64. This is actually a very interesting stat. We'll get to why this number is so high later. It's part of the architecture. The image is not actually downloaded this many times, but GitHub uses the wrong thing to look for this stat. So that's kind of nuts. But we'll get to that in a bit. Okay, so if we're looking at the first part of our architecture diagram, we have GitHub over here. We have a Docker file, and we have GitHub's container registry here. And we have GitHub Actions, which is going to publish images into our container registry here. So this is GitHub Actions. Okay, and this image here, so this is AWC latest, is our image that we will be running inside of our application. So that's kind of the first step and the first thing that I tried to automate, which is going from our Docker file explaining our application into a runnable image. Cool. Okay, so then we got to the next part, which is on Oracle's side. So this is in Oracle Cloud. I should probably make that box a little bit bigger. There are quite a few moving parts inside Oracle. I'm not going to go over all of them today, but we're just going to do some of them. Okay, so inside Oracle Cloud, we have a running instance of a machine, and what this instance did in tmux manually, so imagine I had a manual tmux here, is it pulled down this image, and then I manually put credentials on the box. This was kind of the V1 of this. And I had Podman, which is a alternative container runtime, run this container, Podman container. This is kind of the V1 of this, where I made a Docker image, I have tmux, I run Podman, and honestly, this is good enough. This is probably, I probably could have stopped here, been happy with this. This probably would have had, probably 90+% uptime. I wouldn't have had to look at it. tmux is fairly good about keeping things alive. And this could have run for an extremely long time without me ever having to look at it. But I wanted to go a little bit further because manually clicking around in the console felt gross, manually installing packages felt gross, manually putting credentials onto the box also felt a little bit gross. So I wanted to automate this further. And the way that I usually automate infrastructure is using Terraform. Now, I've done a video on Terraform, so I'll link that in the description. Terraform is how I provision, for instance, pre-commit CI. It's what we use at work for provisioning stuff. It's what I've used at previous jobs for provisioning stuff. It's pretty good at doing infrastructure as code. I wanted a way to represent this state here, or at least this execution here, automatically and have it, promote nicely. I also wanted it so if I made a change to the Docker file here and published a new image to GitHub's container registry, this would automatically pick up the new version. That was kind of just icing on the cake if I could get a full end-to-end, continuous deployment system working. Okay, so going from there, I then reached for Terraform. So we put a little bit of Terraform code into GitHub here. And I actually have a separate Terraform repository here that I use to manage my own personal infrastructure. So this is asatilli/Terraform. This is little implementation details. Basically, I used a submodule to pull in the Terraform code from my video bot. I should label this here. Let's see, video bot. Pulled into the Terraform here. I'm using Terraform Cloud to manage my state. Now, Terraform Cloud is pretty cool. It's free to use. So free to use if you're small or tiny or a single person or personal projects or stuff like that. So Terraform Cloud is what manages the actual state of my Terraform. Now, Terraform, again, infrastructure as code. And Terraform Cloud interacts with cloud providers to actually provision things here. I'm going to walk you through the Terraform code very briefly since it's actually fairly straightforward on this. It writes code AWC video bot. I probably could have done this in the browser. And all of the Terraform code lives in this single main.tf file. There's also this versions.tf because I needed to use the right Oracle provider. There's actually 2 of them. Which was definitely a big confusion point, but I got there eventually in order to set up the Terraform. This is one of the downsides of Oracle. Getting set up with Terraform requires a lot of stuff. There's like a bunch of IDs, you need a private key, you need a fingerprint, you need to write region. I mean, the region, that's fairly straightforward. The rest of this is a lot more complicated. For instance, with AWS, you just need your key pair, your access key and your access secret. Whereas this is a little bit more involved. But once you figure it out, it's pretty easy to do. I also made a Terraform module, which has a few inputs. Oh, this is actually wrong. There needs to be one more input here that I forgot to document, but that's fine. And then this is the main. This is where I have set up all of the infrastructure for this. There are quite a few things that go into this. Oracle tends to group resources by compartments. If you're familiar with Azure, this is like Azure's resource groups. AWS doesn't really have an equivalent to this. I guess you could use separate accounts to do this, but Oracle lets you bucket things, which is kind of nice. So that's what this compartment is. I set up Oracle's Vault in order to store the secrets. That way I didn't have to have those sort of hanging out in plain text on the image or me having to manually copy them to the instance. So I've got a little vault there. I have the 2 secrets for the bot config and the bot token. Those are the 2 inputs to the program. I had to set up the network stack. This is the most complicated part and the part that I understood the least. In order for a Oracle Cloud instance to connect to the outside world, it has to have a network setup. When you click through in the console, it does this all automatically for you, but figuring this out in code took me probably the longest time. There are resources which do this all for you. I didn't want to use them, so I wanted to learn the nitty-gritty. So that's why I'm using, the OCI modules directly, or the OCI resources directly. So anyway, this is all of the network stuff, and then we have security list. This is also part of the network stuff. Blah 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 blah. And finally, we get to the actual instance. So I wanted to run on Ubuntu 22.04, and I wanted an instance. Okay, cool, that's all fine and dandy. This is how you specify the instance. I can SSH to it if I need to, which is where this comes in. So I have a public key here. And then this is the actual thinking bits of how this thing starts up. And I'll describe this a little bit in a second. But user data is a script that runs when the instance boots for the first time. It's commonly referred to as Cloud-init, and it's usually a way to take an image and do some little amount of customization as the instance boots. I actually use Cloud-init here to set up all of the rest of the code that I need. So it's going to install packages, it's going to set up the services, and it's going to run systemd, which is how I'm going to use to manage the different services that I'm running. And then finally, the last part of the Terraform is just allowing that instance to read secrets. So I needed these two rules to read secrets out of that vault. And that's kind of all the Terraform setup. And so the Terraform is going to provision this instance and all the infrastructure over here. And I'm going to go into more details about all of the stuff that we run on this instance in order to, kind of feed this whole system together. So we're going to open another paint to do that. Okay, so now we're on our instance, and these are all the things that Cloud-init has to set up at boot. So the first thing that it needs to do is it needs to install packages. And in our case, we really only care about a few packages. We care about Podman and things that it needs, which Podman, the package itself, doesn't depend on by itself, but that's another thing. And I also installed JQ. This is a JSON querying utility, which I use to read the responses from the Oracle command line. The next thing that it needs to do is it needs to set up a user. I wanted to run all of this in user space, so I didn't need root for any of the special execution stuff. So I set up a separate user called runner. This way I can run things with least privilege and not be super worried about somebody taking over this instance and running crypto miners as root or something like that. The next part of this is to set up the services. These are long-running processes that are going to be actually executing the container, and I'm going to be using systemd for this. I set up a bunch of systemd units. I actually used a lot of the learnings that I gained from building pre-commit CI to run these, so I had a little bit of knowledge coming into this that helped me set those up. And then finally, it's start everything. Now, this is quite a lot to do in Cloud-init. Usually I wouldn't want to do this much, but I didn't want to have to bake an image or do any sort of other slower processes. And this is good enough. Honestly, tmux was good enough. This is already overkill. So I did all of this inside of Cloud-init. And once this is run, it sets up 3 separate services. The first one is a hack, and I still don't completely understand why I need it, but that's fine. The first one is called Podman Placeholder. And this one, this one is literally so that Podman doesn't leak a process. And I don't quite completely understand why this is necessary, but that's the first service. Not important, but this is something I learned while building pre-commit CI, and so I needed it here. And the next service is the actual worker service. This is the one that runs Podman, and Podman runs our app. And then the other is our updater service. And what this does is it pulls the latest image version. And right now it does this every 60 seconds, which is why we see that giant download count on this here, because it's just asking what the latest version is. It's not actually pulling the image. And if it sees a new version, restart the app. That way, if the updater notices something has changed, it will say, hey, worker, you should pull the latest image and start again. And this is basically how this gets set up. Now, I wanted to walk you through the script that does this, since we talk about the Cloud-init, but I didn't actually show you. And I'm not proud of this. This is some really, in my opinion, kind of gross code because it's a shell script, but also it's a shell script inside of a shell script. And parts of this are okay, but let's walk through the steps that I talked about before. Okay, so first, install packages, JQ, and Podman. These other things are to allow Podman to run with overlayFS and set up network namespaces and do user ID mapping for rootless. I don't know why they're not provided by default or required by default, but whatever. Next was set up the user. I needed to set this that way if the machine restarted, this would still run that user's systemd processes. And then I set up the actual shell scripts that run the units. So the first is our worker. The worker involves retrieving the secrets. Now I actually used a pretty clever thing here, which is I was looking all the install instructions for how to install the Oracle Cloud command line tools, and it's complicated for reasons. It's either curl shell script or run this pip install command or install a bunch of headers and other stuff. And I was like, wait a minute, surely there's a Docker image for this. And actually Oracle provides one for you. So it's really easy for me to use the Oracle command line directly from Podman. So again, I'm using containers wherever I can to avoid having to install software. Now, one thing I also learned here is if you use auth instance principle, this is how I was able to use that Terraform code that makes me automatically be able to read secrets from my vault without having to set up Oracle credentials on the box too, because that would have been even more of a pain in the butt. But yeah, so I can retrieve secrets, and then I use JQ to retrieve the secret content. That way I can actually pass those secrets onto the container. This JQ expression I've got probably 6 or 7 times wrong. This is probably the place that I made the most bugs while building this piece of software. But yeah, after that, it sets those to environment variables. It inspects the manifest of the current image and writes that to a little file. This file is what I use to know whether I need to update or not. And we'll get to that in a bit. And then finally, it runs the bot. This is the actual execution of the bot. Passes along those two environment variables. Pull equals always, that way it uses the latest version whenever it starts, and it gives it a name. That way we can interact with this container later. That brings us to our updater. Our updater looks at that same file. It also tries to look at the latest version of the manifest. If they are different, it's going to stop this. So stop this container here, and rely on systemd to restart it again and pull the latest image and start with the latest one. This is basically how the updater works. There's a small improvement that I could do here, which is I could probably pre-pull the image. So I could probably podman pull ghcr.io, blah, blah, blah. That way the downtime is minimized. Of course, you're either gonna have 2 instances running at once or 0 instances running at some point, because there isn't really an HA way to do HA being high availability. There isn't a high availability way to make a Discord bot. Well, I guess you could put proxies and do all sorts of funny handoff and stuff, but this works well enough. This is already over-engineered. I don't want to go further. Okay, so those are the 2 scripts that run as part of the systemd units, and then finally we're going to set up those systemd units. This first one is that, again, that Podman placeholder service that I talked about before, which is literally to hold the Podman process. For some reason, this leaks a process, and if it's in the process tree of another systemd unit, that systemd unit will never stop because it still has a running process. So this just sequesters that extra process into a placeholder unit. But yeah, otherwise it's sleep infinity, does nothing. Then we get to our worker service. I wanted to run that as our particular user. It's just going to run that little shell script. And this is the important part that makes it restart when it stops. So when I stop that container, this systemd is going to automatically restart this. Now, another thing that I can probably improve here now that I mentioned that, this is just a busy sleep loop. There is actually a way to do this in systemd using timers. I knew this would work, so I just went with it. I might, make a future improvement to this to use timers instead. Or maybe you know how to use timers and can send a pull request to this bot. I don't know. Go for it. Right, okay, so that's our worker, and then finally we get to our updater, which is very similar to this, except it's going to run the updater instead. And that's basically it. At the end, you start all the systemd units and it pulls it all together. So that's how this is architected. The cool thing about this is now if I want to make changes, all I have to do is push to the actual Git repository. It's going to build the image that gets promoted here. The little updater is going to pull for the latest version. If it notices there's a new version, it's going to download it and run it immediately. So it all kind of fits together. I did want to go over my overall opinion of Oracle Cloud kind of at the end, because it is enterprisey, and usually people are like, bah, Oracle bad. Oracle Cloud was actually kind of fine here. Everything was pretty easy to get set up. Again, the credentials was a little bit weird. Having to set up a private key and a bunch of other stuff was way more work than, say, setting up the auth token for AWS or setting up the auth token for Azure. Like, that part was a little bit worse. The Cloud Console, clicking around in the browser, those suck in every cloud provider. So Oracle's wasn't any worse than the other ones. In fact, in some ways, it was a little bit better. I think the container stuff was confusing at first, but once I understood that idea, the Cloud Console made a lot more sense. Mostly that if you're not in the right container, it won't show the resources. So you kind of have to bounce around to the right container to make sure you're looking at the right resources. The other thing is when I went to clean up my manually created resources, that didn't work. I went to delete the network for the thing that I created, and it just errored. And the reason it errored is because networks are somewhat cyclical in how they get defined. Like there's a VCN, which references a route table, which references like a internet gateway, and the internet gateway references the VCN. And so there's a cycle in there. And so when you try and delete, it errors, and I had to manually find where the cycle is and delete it that way. Now, if I was using Terraform would just handle this for me and tear it down, and I wouldn't have to worry about that. It would fix that cycle and auto delete for me. So that was kind of a pain, but I honestly can't complain. I'm getting all these resources for free, and it replaces Heroku for me. Now, granted, the deploy the deploy experience and execution of Heroku was much nicer. I didn't have to write any infrastructure. I literally just, well, I didn't even do it. Shaz had to write runtime Python and Python-m this thing and put some creds inside of environment variables, and that was all Shaz had to do. Whereas doing Terraform was way more work. But I don't know. I spent 15 hours on this, and I learned a lot. Is it worth spending 15 hours to run a Discord bot in a infrastructure as code, Terraform setup, cloud native, blah, blah, blah? Absolutely not. But I learned a bunch along the way, and I wanted to share some of the things that I learned. Anyway, hopefully you found this useful, and I will see you in the next one.